So welcome back students for the second session in solving some of the MCQs related to the haloalkanes and then the haloarenes. Okay. So now we will move on to the which one? Numerical number 25th, because as if in the first session we have discussed the 24, I think. 25th is of the isomeric hexanes, the isomers that gives the minimum and then the maximum number of monochloro derivatives are respectively. N is the number of type of hydrogen atoms, then N is the number of mono-substituted benzenes or alkanes, substituted compounds. Means if any compound contains what? N number of types of hydrogen, not the number of hydrogen, it is a type of hydrogens. Then we are getting those number of which one? Mono-substituted compounds. Okay. Hexane means we can say it is called C6H14. C6H14. What are the various possibility here? CH3, CH2, 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 CH3. 1, 2, 3, 4, 5, 6. Okay. Then branching now. Let's have the branching here. CH3, CH, CH3, CH2, CH3. 2-methyl, 1, 2, 3, 4, 5. Okay. Next we will have the what? Suppose if I have the branching at the third carbon atom. This is 2-methyl butane, this is 3-methyl butane, but not 4-methyl. 4-methyl is similar to that of which one? 2-methyl. Okay. So methyl is right now here. Then we will have the what? Dimethyls now. 2,2-dimethyl butane. 2,2-dimethyl butane. But it cannot be 3,3. 3,3 is similar to that of this. Therefore, there is no possibility here. Therefore, another one is 2,3-dimethyl butane. 2,3 what? Dimethyl butane. So means methane has only one, ethane has only one, propane has only one, butane has two, N-butane and isobutane. Pentane has 3. What are those? N-pentane, isopentane and then neopentane. In addition to that, we can have another one, I think. I think the neopentane is obtained here already. Okay. So therefore it is hexane, 2-methyl pentane, 3-methyl pentane, 2,2-dimethyl pentane, 2,3-dimethyl, 2,2-dimethyl butane, 2,3-dimethyl butane. How many types of hydrogens are there? This is one type, CH3CH3. Okay. These two are very similar. And these two are similar. Means how many types? 3 types are there. Not 3 types of this one, 3 types of different types of hydrogens. Okay. Let's have this. This is one set, but this is different from that of CH3. Why? Because these two CH3 is attached to CH, but this CH3 is attached to CH. Therefore, this is second type. This is third type. This is fourth type. This is fifth type. 1, 2, 3, 4, 5. 5 types of hydrogens are there. There it is 3 types. Here, I think these two are same. This is one category, but this is different from this second one. These two are of another one, and this is one. 1, 2, 3, and then 4. 4 types of hydrogens are there. Next here, I think these 3 are same, one type. Here it doesn't undergo mono substitution, because why? Because there is no hydrogens here. Therefore, we can't have second type and then the third type. 3 type. Here, can you say that all these 4 are same here? All the 4. And these 2 are found to be the same. Therefore, it is found to be the what? 2. Means, what I ask here? Minimum and maximum here. Here it is 3, here it is 5, here it is 4, here it is 3, here it is 2. Which is the minimum here? Minimum is called as 2,3-dimethyl butane. 2,3-dimethyl butane. Means I can delete which and which? AC is deleted. Because as if it is 2, 3. Next, 2, 3. After that, it is the maximum. Maximum means here it is 3, here it is 4, here it is 5, here it is 3. 5 means it is called which methyl? 2-methyl pentane. What methyl pentane? Here it is 2-methyl pentane. Therefore, it is not this, hence it is. Means in any substance for the isomers, if it is having n different types of hydrogen atoms that has been attached to the carbon atom, then we are having n number of or same number of mono substituted compounds. Okay, so that is 25D. Let's have the 26th here. 1,2-dibromocyclohexane on dehydrohalogenation gives. I think can I rub this? Let's move on to the 26th here. What is that 26th here? 1,2, what is that? Dibromo. 1,2-dibromocyclohexane on dehydrogenation gives what? So first we will have the options here, as if it is not printed here. Question number 26. The 26th is A is benzene, so here it is C is it is none of this. What they have asked here? 1,2. What is that? 1,2-dibromo what? Cyclohexane. Cyclohexane. Sorry, cyclohexane. Sorry. There is no presence of double bonds here. This is called 1,2-dibromo what? Cyclohexane. First we have to remove the what? Bromine, and from the adjacent carbon atom we have to remove the what? Hydrogens. This contains I think CH, this contains CH, this contains CH2, this contains CH2 and this contains the CH2 here. If this be the case, we have to remove from the least according to the Satter's rule. But here is already there is another bromine atom here, therefore we can remove this. Means there is a removal of minus HBr. If that be the case, I can expect the double bond here between them. Okay. Next, if I remove another hydrogens here, dehydrohalogenation, means we have to remove the hydrogen from this. It is CH. If it is CH means no doubt it is, but there is a presence of already the double bond between them. Hence it is we have to remove this one. Means where we have to get the double bond here. Means here I am getting the double bond. Here also I am getting the double bond. This is called benz. 1,3 diene. What comma what? 1,3 diene. Means where I am expecting. This is similar to that of B. Dehydrohalogenation of 1,2 dibromocyclohexane leads to what? Benz 1,3 what in? Diene. Okay. So let's have the 27th now. The structure of the major product formed in the following reaction is. I think the reaction is not written here. Just I will write that. The structure of the following reaction. What is that reaction here? 27th. The 27th means the reaction is benzene. First we are having Cl. Here it is I. The options are Cn. B is I with NC or Cn. C is Cl. Here it is Cn. And lastly, D is Cn with what? I. So first this is a reactant. What is the reactant here? The reactant is this one. What is that? Benzene Cl with I. This made to react with NaCN in presence of a solvent. What is that solvent called as? DMF. DF means is called dimethyl formamide. What is that called? Dimethyl formamide. An example for a aprotic solvent. What is that solvent called as? Aprotic. Means it doesn't have the what? Proton. Water, ammonia, they are the solvents having the protons. They are called as protic solvent. But here it is aprotic solvents. So here Na plus and then Cl minus. This is called aryl. There is no possibility of NSR directly. But this is R-alkyl. R-alkyl readily undergo what? NSR. So nucleophile here, it is a Cl. Cl minus. Means what to replace by what? Just Rx with what? NaCN gives rise to RCN plus NaX. Means instead of X we have to put the what? Cl. Means there is no attachment of cyanide here because it is aryl group. Only the what? R-alkyl. Where that R-alkyl here it is. Here in this case both the cyanides has been present. No, it is not possible. Here it is not possible. Here it is not possible. Therefore it is D. Means the option is found to be the D. Means we are having the benzene with side sign CH2 with Cn along with the retaining of the water I. Okay, that is 27 in the form of D. 28. Consider the following reaction. CH3 CHD. D means it is called a deuterated hydrogen. CH3 CH3 plus Br dot. Br dot means it is called as bromine free radical. What radical it is? Bromine free radical gives rise to X plus HBr. Then what that X is, I think. Here what that structure of X is. CH3 CHD CH CH3 CH3. This is alkane. I don't know the name of that one right now. As if I already mentioned, the alkanes readily react with halogen to form respective haloalkanes according to the free radical mechanism. Here is the free radical here. Yes. The stability of free radical is of the order again. It is similar to that of carbocation. What is that greater than? What is it greater than what? Tertiary greater than, secondary greater than primary. Means this is primary carbon, this is primary carbon, this is also primary carbon, this is also primary carbon. Means we can't attach these two. Next here, the possibilities where we have to remove. Either we have to remove, so here it is only the H, I think. It is only the, indirectly it is called as H. So therefore it is called as secondary carbocation. But this is tertiary carbocation. Tertiary carbocation. The stability order is what? Tertiary greater than, secondary greater than primary. Therefore the option is CH3 CHD as it is with CCH3 with CH3, and there is an attachment of what? H has been removed. H is removed in the form of H dot. H dot plus Br minus is removed in the form of what? HBr, and the X obtained is found to be the, this is the case. So where that option is? It is not in the A, CH2 dot, here it is. I think it is in the B, maybe, might be possible here. It is B. CH3, CHD, C dot surrounded by what? CS3 and CH3. That is 28B. Because it is on the basis of what mechanism? Free radical mechanism. Free radical mechanism is of the order what is greater than what is greater than what? Again, tertiary greater than, secondary greater than primary. Okay, 28B. Let's have the 29th here. Reaction of a trans 2-phenyl 1-bromocyclopentane. 1-bromocyclopentane on reaction with what? Aqueous, alcoholic KOH produces what? Aqueous produces what? Cyclopentane first. This is cyclopentane. 2-phenyl 1-bromo cyclopentane. What phenyl? Trans 2-phenyl 1-bromo. PH H 1-bromo BrH. Here, where the 2H and where the 2 phenyls are, this is first carbon atom, this is second carbon atom. Okay? Then reaction with alcoholic KOH. Alcoholic KOH. According to this, as it is a trans means it is called a elimination first. Elimination means it is called as a DHH. Whether the elimination is in the same or the opposite, it is opposite. That is why it is called as anti-elimination. Why it is called anti? Because H and Br are on the opposite here. That is why it is called as, means it is occurring at the dihedral angle of how much degree? 180 degree. As if this is plane means they are in opposite, means it is going to be the what? Dihedral angle is 180. Then what we have to do here? If I remove this bromine, then so first we have to remove the bromine, and from the adjacent we have to remove the what? Hydrogen. If that be the case, we can expect the double bond here. The product is here Br, here it is H. Means here it is not possible. We can have the double bond here. PH, H, retainments of H as usual with the double bond formation. As if already the pH is present, means there is no removal of what? H is not possible from the adjacent carbon atom. I can put here H and H like this also. Means we can remove this because it is anti-elimination, because it is a cis product or a trans product. It is a trans product. That is why the dihedral angle is going to be how much? 180. At this there is a formation of a what bond? Double bond. What is the name of this compound? It is first cyclopentene, no doubt. But 1, 2, or we can say that it is 1, 2. If it is 1, no, it is, if it is 1, here it is 2. 1, 2, 3. 3-phenyl. 3-phenyl cyclopentane. 3-phenyl cyclopentane. Therefore, it is the option is going to be this. Means it is according to the elimination, means it is a trans, means it is called as against to the elimination, which is at the dihedral angle of how much? 180. Therefore, the product obtained is not the 2-cyclo or 2-phenyl cyclopentane, it is the 3-phenyl cyclopentane. That is 29 in the form of D. Let's move on to the 30th here. In order to get what? In order to get the ethane thiol from C to H by Br, the reagent that has been used is Rx plus KOH gives rise to ROH plus that. It is alcohol. Suppose if it made to react with KSH or NaSH or NaSH. We are getting RSH because it is plus and here it is minus. This is called as thioalcohols. What is that called as? Thioalcohols. Okay. So thioalcohols means it is called as, means instead of KOH, if the KSH or NaSH may be present, here it is Na2SNH. Here it is this. Okay. OH minus in case of organic is called as alcohol, whereas the OH in case of inorganic is called as hydroxide. You have to remember that. SH in case of organic is a functional group called as thiol or thioalcohol, whereas the SH minus in case of inorganic substance is going to be the mercapto, we are calling that as. Yes. SH minus is called as what? Mercapto. Means it is called sodium mercaptide or potassium mercaptide. They form a respective alcohol called as thioalcohol. Okay. So that is about the numerical, MCQ number 30, and the option is going to be the B. Let's have the 31st here. Which one is the most reactive towards the what? SN1 here. SN1 means usually we are preferring primary, SN1 refers to what? SN1 refers to order tertiary greater than, secondary greater than primary in case of the stability of C plus already. Okay. In case of this A, C6H5, CH, CH, CH5 with Br, C6H5CH CH3Br, C6H5C CH3 CH5Br, and then this one. So here, if I remove this bromide, here it is plus. Can I say it is C plus and this one is going to be the second? If I remove this bromine, I am getting the carbon here. This carbon is surrounded with CH5 and CH3, again it is going to be the second. If I remove this bromide, it becomes the C now. C is carrying the C plus. C plus means it is C plus is surrounded with CH5, CH3 and CH5. It is going to be the tertiary. Here it is. Br means it is going to be the plus. Plus means it is called as pi. Therefore, which is going to be the more stabilized here? Even though all are R alkyl groups, all are, first you have to remember, all are R alkyl groups. Among that R alkyl group, we are having primary, secondary and tertiary. What is the order here? It is the tertiary. Therefore, it is going to be the C. 31 in the form of what? C. 31 in the form of what? C. Let's move on to 32 here. 32. The following compound on hydrolysis gives what and what? In aqueous acetone gives what? The following compound on hydrolysis gives, in aqueous acetone gives mixture of KLM. First I have to write the reaction for that. What's the reaction here? First I want to write the reaction. Okay, so here it is NO2, here it is OCH, they are CH3O, ME means it is called as methyl group, CH3 groups. Okay, apart from that we are having the H, then Cl and Me. This is the reagent now. Okay, here K is CH3O, NO2, Me. Here it is H with what? OH, Me. Then L is CH3O, NO2, then same Me, and then Me, and the L option is going to be the OH here, H here, Me here. And then we are having another one that is called as KLM, I think. M is also present here. CH3O with another benzene. NO2 here. Me here. Then followed by HClOH. H, Me, here it is OH. So here the question is, the following compound, this compound, upon which one? Hydrolysis in presence of aqueous. Here, hydrolysis means we have to think only on what? Cl. Because this is alkyl or R alkyl? R alkyl group. R alkyl means readily undergo NSR to form respective alcohols. Therefore, one Cl has been replaced by what? This has to be replaced by OH. Therefore, I can have the possibility of this. Okay? In the second case, it has been attached to here. Where it is true or false here. Suppose if I remove this hydrogen, what happens here? If I remove this chlorine, it becomes a carbocation. And this is moving to this by 1, 2 H minus shift, such that the positive charge here. But whether this positive charge carrying is going to be stable or unstable, as OCH3 is ERG, it increases the stability of Yao plus C plus. Therefore, I can have the possibility of this also. But not in case of this one. Why? Because NO2 is EWDG. What is a DWDG? Decreases the stability of which one? C plus. Means regularly Cl is directly replaced by OH in case of which one? K. Apart from that, we can shift this to left also. Why? Because this carbocation after the removal rearranges by 1, 2 H minus shift. There also it is getting tertiary carbocation, but that tertiary carbocation is further stabilized by the electron releasing groups. Therefore, we can have the possibility in the L also, but not in the third option of M, because NOD is electron withdrawing. Electron withdrawing always decreases the stability of what cation? Carbocation. Therefore, I can expect both which and which. Okay. So this is the hydrolysis of this compound in case of the aqueous acetone. Okay. So that is 32 in the form of A. Let's move to the 33 here. Reaction of tertiary butyl bromide with sodium methoxide produces what? Sodium methoxide produces what? Tertiary butyl bromide with sodium methoxide. What's it here? Reaction of tertiary butyl bromide with sodium methoxide. Tertiary butyl bromide. This is tertiary butyl bromide with sodium methoxide. Sodium methoxide. So here it is indirectly called as a CH3O minus in presence of alcohol. Means it undergo not NSR but which one? Not NSR, but it is going to be the what? DHH. What is DHH? Dehydro which one? Halogenation. Usually tertiary haloalkanes doesn't easily undergo which one? DHH, but instead they undergo what? They doesn't easily undergo NSR, but instead of that they undergo what? DHH. That is called as dehydrohalogenation. Dehydrohalogenation. That's why we are preferring in the form of what? First, we have to remove this. The formation of a carbocation. Carbocation. As if it is having the alcoholic medium, alcoholic sodium substances are using as a DHH, but not an example for a nucleophiles. Means we have to remove the hydrogen from the adjacent. Either I can remove from this. Why? Because all these are symmetrical. Therefore, I can remove this. Therefore, it is minus what Br? HBr. That HBr made to react with this to form NaBr with minus CH3OH. These are the byproducts. Apart from that, I am getting the product as CH3. Removal of this leads to alkenes. Alkenes means this. 2-methylpropene. 2-methylpropene is also called as isobutylene. This is isogroup here. Totally 4 carbon atoms butylene, and at the second position we are calling that as isobutylene. That is why 33 refers to B. Okay. 34 here. Alkyl halides made to react with what? Dialkyl lithium cuprate to give what? It is observed both in the first as well as the second year. In the preparation of alkenes, we are concentrating that reaction. Alkyl halides made to react with dialkyl lithium cuprate to form RR dash plus R-Cu plus Li. This is called as respective alkenes, preferably the higher alkenes. And the name of this one reaction is called as Corey-House synthesis. Corey-House synthesis. The preparation of which one? Alkenes from haloalkanes. The very simplest method that we have discussed is the reduction of haloalkanes gives rise to alkanes, but it contains same number of carbon atoms. But the same reduction of haloalkanes gives rise to higher alkanes by using dialkyl lithium cuprate, and the name of that reaction is called as Corey-House synthesis. Hence it is the preparation of which one? Alkanes. 34 in the form of B. Let's have the 35 here. Ethyl bromide reacts with a lead sodium alloy or sodium lead alloy to form what? The best reagent to reduce the noise of a vehicle by added of petrol. That is C2H5Br, ethyl bromide made to react with alloy. What is that alloy here? NaPb, sodium lead alloy to form C2H5 twice Pb plus NaBr plus Bb. You relabel this one. This is called a TEL. What is TEL? Tetraethyl lead, which is an example for an anti-knock for petrol. Means the petrol, the naturally occurring petrol has been treated with a lead component in the form of which one? Tetraethyl lead. That is what is called as a leaded petrol that reduces the noise of the vehicle during its combustion. That is what is called as TEL or tetraethyl lead. So 35A, 36 here. Fluorobenzene can be synthesized in the laboratory. How? By heating phenol with this. Then from aniline diazotization and followed by heating with the diazonium salt with fluoroboric acid. Direct fluorination of benzene using fluorine gas by direct fluorinate the bromobenzene with NaF in this one. So I think you heard about the Sandmeyer's reaction. Sandmeyer's reaction is applicable for the preparation of chlorobenzene and then the bromobenzene, but not the fluorobenzene. Then how it is done? When aniline, what is it aniline here? NH2. Upon diazotization, what is the diazotization? Using what? Na between what? HCl at 0 to 5 degrees Celsius. We are getting BDC. What is that BDC called? Benzene diazonium chloride. This on treating with fluoroboric acid. What is that fluoroboric acid here? It is HBF4 minus HCl to form benzene diazonium fluoride. This upon heating, there is a removal of boron trifluoride to form what? Benzene. Fluorobenzene. Means the fluorination of benzene is not directly possible to get the fluorobenzene. Why? Because it is highly explosive, as if already I have mentioned. Okay? For that, aniline has to be first diazotized to form benzene diazonium chloride, followed by treating with the fluoroboric acid. What's it called? Fluoroboric acid. First it forms actually benzene diazonium tetrafluoroborate. But I have not written that. Benzene diazonium tetrafluoroborate. Upon heating it converted into what? BF4 with much, and then finally it forms a what? Benzene. Fluorobenzene. Okay? Or I can move in that process also. N2 plus BF4 minus. What is that called? Benzene diazonium tetrafluoroborate, which upon heating it converted into what? Borate with along the removal of N2 gas. Okay? So therefore it is from aniline B. 36 B. Let's have the 37 here. Ethylene dichloride can be prepared by the reaction of HCl, ethylene dichloride. Even in the first PU we will have the same concept from the chapter called as alkenes. Ethylene dichloride is obtained. How? By treating with HCl with what? Ethane doesn't react with this. HCl plus ethane. Ethane means CH3CH3. Ethylene means CH2 double bond CH2. Acetylene means CH triple bond CH. And then ethylene glycol means CH2OH. Okay? No reaction. Saturated, no reaction. So here it is respective alkane. So here it is. Means I have to add 2 molecules of that. CCl, HCl. In case of this, HCl means there is a readily replacement of this. Which is the ethylene dichloride here. This is called ethylene dichloride. From which alcohol? Ethylene glycol. Okay. So that is 37 in the form of sorry. First it forms this and then CH3 CHCl. This is called as ethylene chloride. Which is that? Ethylene chloride is obtained using acetylene, whereas ethylene dichloride is obtained from what alcohol? Ethylene glycol. 37D. Let's have the 38 here. Among the following, the molecule with the highest dipole moment is. Among the various haloalkanes, the order of dipole moment is RCl greater than RF greater than RBr greater than Ri. There is a dipole moment with respect to Rx. I think this you all know about the reasons for the electron gain enthalpy. What's that electron gain enthalpy? Electron gain enthalpy of fluorine is found to be less than that of what? Chlorine. An exception in halogens. Why? Fluorine being a smaller atomic size, what happens? The added electron have the more repulsion compared to that of attraction. That is why what happens? The chlorine gets an advantage of electron gain enthalpy compared to that of fluorine, bromine and this one. Okay? But here we are having what? CH3Cl delta minus delta plus. Then we are having the CH2 F and F, for example. Here we are having CH, Cl, 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 and here Cl, 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 Cl. Okay? All are tetrahedral, all are saturated here. So this dipole moment is equal to 0. Why? Why is 0? Because it is symmetrical. As if it is symmetrical means we can have the direct cancellation on the opposite side. That is why its dipole moment is going to be the 0. So here next comes this chloroform. This is positive and this is negative. Here little bit negative and little bit positive here. That is not symmetrical here. But here it is purely highest dipole moment is observed in case of this. Means methyl chloride is having the highest dipole moment. Then comes the chloroform, and after that we are then comes the methylene chloride and then the chloroform, and 0 in case of which one? CC here 4. So but here as the highest dipole moment is observed in case of which one? Methyl chloride. Okay, 38 in the form of A. 39. Which one of the following chlorohydrocarbons readily undergoes solvolysis? Hydrolysis is also called as solvolysis here. Instead of water, if I use any solvent, it is called as what? Hydrolysis. Breaking up of a substance in presence of water or any solvent is called as solvolysis. Hydrolysis is indirectly the NSR. NSR means it is in case of saturated. Why? This is alkenyl, means it is sp2 I think, and this is also sp2 because HaloAlkanes is sp2. sp2 means it doesn't undergo hydrolysis. Therefore we can have the two positives. What's that? The first one is C6H5CH2Cl. Another one is C6H5CH2CH2Cl. For hydrolysis, we should have the attachment of what? OH minus. This is benzyl carbocation. It's more stable by the phenomenon called as what? Resonance. Therefore, that is possible. It can have this. Now here, this is primary CC. Primary CC. Now, if there is a removal of Cl minus here, I am getting the carbocation. But here, this is converted into C6H5, CH plus CH3. Why? Because 1, 2 what shift? H minus is shift. Means one of the hydrogen has been shifted here. Such that it is converted to secondary CC. Both are R-alkyl, both are stable. But which is more stable among primary and secondary here? It is a secondary. Therefore, it is fast. Fast is in case of, I think he has asked the fast as readily undergo. Readily undergo means it is fast. Fast is found to be C6H5CH2CH2Cl. Okay, so I think it's clear about that. Benzyl chloride, no doubt, it also undergo what? Solvolysis. But it is not possible in case of sp2 hybridized carbon, that is in the form of A and then B. Now it is found to be the D here, 39D. When CCl4 is boiled with KOH, the product formed is what? What that product formed when it is treated with which one? CH3Cl, CH2Cl2, CHCl3, CCl4. I will write all this one. What happens when they meet to react with KOH? They form respective alcohol, CH3OH. Yes, that is product. So here it forms CH2OH and OH. Here it forms CH, OH, OH, OH. Again unstable. Here C, OH, 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 OH. These type of compounds are unstable. These three are unstable. Why? A carbon surrounded by one OH is always stable, but not either the 2 or a 3 or a 4. Means it undergo dehydration, removal of water to form CH2O is called as formaldehyde. Means methylene chloride undergo hydrolysis with KOH to form formaldehyde as a product. Here, what happens here? Removal of this to form formic acid. What is that? Formic acid. Here, what happens here? H2O, H2. What I left with? There is a removal of 2 molecules of water. I left with only the carbon dioxide. He has asked the CCl4 with KOH. CCl4 with KOH gives rise to the main product is going to be the what? If it is methylene chloride, it is called as formaldehyde. If it is chloroform, it is called as formic acid. If it is methyl chloride, we are getting the what? Methyl alcohol. So here, with respect to CCl4, it is the carbon dioxide. Okay. So let's have the 41st. The major product A in that particular reaction is what? Let's have the taking off. Which one? We'll write that particular reaction. I think 41st. The major product, I will write the reaction for that. OCH3 with what? Cl. With what is that? Sodamide in liquid ammonia, NaNH2 liquid ammonia. Here I will write the products as ABCD here. OCH3 with NH2. B is OCH3 with NH2 at the meta position, OCH3 with NH2 at the ortho position, OCH3 with Cl, OCH3 with the DL, D is found to be the Cl. At this position we are having the, okay. So which is the product that has been formed here now? Sodamide means, it is called sodamide. It's the best example for dehydrohalogenating agent. Alcoholic KOH or potash along with sodamide, they are the best examples for what? Dehydrohalogenation. Means there is a removal of this. From the same other adjacent carbon atom, adjacent. I can remove either from H or H here. Therefore, it first forms, as usual, OCH3, double bond, double bond, double bond. Between these two, for example, there is a removal of hydrogen here. This is called through the benzene as an intermediate. What's that intermediate here? The benzene as an intermediate. Now, we have to add the what? NaNH2. Liquid ammonia. Means here now it undergo what? Nucleophilic substitution reaction. So what is that? NH2 minus, where it has to be attached here. Whether it is at the 41st, that is in the form of what? Intermediate form is found to be the what? Benzene. Why it is called benzene? Because there is a formation of a triple bond. Now it is an attachment of a what? NH2 minus. Where it has to be attached? OCH3 is electron releasing. Electron releasing. Electron releasing favors either the ortho or it may be the para. But here it is not possible, here it is possible. Hence it is found to be the. Okay? Means instead of directly undergoing the dehydrohalogen, undergoing the nucleophilic substitution reaction, first it undergo DHH. What is DHH is called? Dehydrohalogenation using sodamide to form an intermediate compound called as benzene. And that benzene is attacked by the nucleophile in the form of NH2 minus at the which position? Para position. Therefore, it is called as para-amino methoxybenzene, or it is also called as anisole we are calling. This is called as anisole. What anisole it is? Sorry, it is not anisole, it is benzenamine is the main product first. Aniline. Therefore, it is called as para-methoxyaniline. This product is called Paramethoxyaniline. Paramethoxyaniline. That is 41 in the form of A. Let's have the 42 here. Again, predict the product. Okay. Again, we'll have the what? Predict the product. First I have to write the equation for that, reaction for that. First, 42. 42 is, I'll write the reaction. OH. The first is PBr3. The second one is alcoholic KOH. I will write the products related to that. The product is this one, R, OH, ROH here. Then C is OH here, R. Okay? Predict the product now. This is the reactant here, reaction here. The products are there. Whether it is an alcohol or a phenol, first you have to decide. If OH group is directly linked to the aromatic nucleus, then they are called as phenols. But as if it is not a benzene. It is cyclohexanol. It is called as cyclohexanol. An example for a what? Alcohol. An example for what? Alcohol. What happens when alcohols reacted with PBr? This is indirectly called as P4 bar Br. The best example. When alcohols made to react with PBr3, what's the product? RBr plus H3BO3, H3PO3. Means they form respective bromoalkanes. Here also the same thing. What is that? Sorry. Here there is an attachment of what? Okay. Then the second step is reacting with what? Alcoholic KOH. What is the function of alcoholic KOH? DHH. Means minus HBr. Removal of Br from the same or the adjacent. I can remove this here hydrogen like this, so that I can get the double bond here. Means I am getting the product as like this. This is called as cyclohexene. Hexene, sorry. Cyclohexene. Hence the product is going to be the 42. 42 is A. First, it undergo nucleophilic substitution reactions with the PBr4 with respect to alcohol in the form to form respective bromocyclopropane. This on DHH using alcoholic KOH they form respective cyclohexene. 42 in the form of A. Let's have the 43 now. Which of the following compounds undergo E2 reactions more easily? E2 means it is called elimination. For elimination under C2, elimination under C2. For elimination under C2, the order is removal of which one? HX is done by the, after the removal of X minus, it forms a C plus. C plus must be what? Stabilized. Where the stabilization is secondary greater than primary greater than tertiary in case of what? C plus. That we have to observe first. Okay. If I remove this bromine, it becomes C plus. C plus is surrounded by 2 times carbon. Here it is 1. Therefore, it is called as tertiary. Okay. Yes. If I remove this, it becomes plus. CH2 plus only 1 means it is called as primary. If I remove iodide means here it is plus, here it is again primary. Then if I remove this, again it becomes plus is surrounded by 2 carbon, here it is 2 carbon. Therefore, it is going to be the tertiary. The order is what? Tertiary greater than, secondary greater than, primary. But we are having the two tertiary options here, either A or D. As if I already mentioned, iodides are more reactive than bromides, are more reactive than chlorides, are more reactive than fluorides. Reactivity order. In the previous session I have mentioned. Reactivity order is tertiary greater than secondary greater than primary, and also for various haloalkanes, iodides are more reactive than bromoalkanes, chloroalkanes, and then the fluoroalkanes. Therefore, among bromo and iodo, which is more reactive here? Iodo. Hence, it is found to be the D. Therefore, 43 is found to be the D. Okay. So that is 44 now, right now. 43, sorry. The decreasing order of rate of, what is that? Rate of the above reaction with the nucleophiles, Nu minus, from A to D is found to be the order. The decreasing order they are mentioning. Let us have first PHO. PHO means like this. This is called as PHO. PHO is called as A right now. What is B? AC. AC means what? This is called PHO minus. Then what is ACO minus? Acetate. Acetate means CH3, C double bond O minus. This is called as, I think, B. Okay. Then OH minus. This is called as C, I think. And then third one is, last one is CH3O minus. It is D. Means more the negative charge on oxygen, more is the nucleophilicity. Or indirectly it is lesser is the electronegativity with respect to that atom. Okay? So here O minus is attached to the benzene nucleus. We know that according to the plus M effect, according to what effect? The negative charge gets decreased. More the negative charge, more is the nucleophilicity. But here it is less right now. This is now attached to what? CS3 is electron releasing, no doubt. But the thing is, it is stabilized by what? Resonance. Again, the negative charge gets decreased because it is delocalized. What localized it is? Delocalized. Then we are having neutral here. This is CS3 is electron releasing, therefore it is highest. Means, can I say that the negative charge is more in case of this, followed by C. These are more preferred. Among these two, which is preferred? CS3, because it is electron releasing, followed by OH minus. Next, we'll have the fighting between these two here. What is that? 40 DC, okay, DC, okay, it is B, and then this one. Where the negative charge is very least here, it is in case of A or B. So here the resonance is very fast because they are very adjacent to that. Therefore, it is found to be the what? B now. B greater than formed to be the top. Why? Because this is better stabilized compared to that of acetate. Or phenoxide is better stabilized due to the resonance compared to that of this resonance. Why? Because it is oscillating between them. Hence, the order is to be what? DCBA. DCBA means that refers to this is better stabilized. This is better stabilized means it is want to be the A first, sorry. And then, because this is more stabilized compared to the top, that is why we can have the what? A is greater than B. Means DC in the form of A. That is A. 44. Let's have the 45 here. The reaction described below is whether it is SC1 or SN2 or SN1 or SE2. Let's have it write the reaction for that. Okay, what's the reaction that has been mentioned here? It's very similar, very simple, I think. What's that? 45 question is, I will write here, C. CH3, CH2, 5 times, I think. CH3, BrH. When this made to react with OH minus, the product obtained is HO, single bond C, CH2, 5 times CH3, 5 times CH3 with CH3 and then H. This is the reaction given. I am deleting first this and this. Why? Just the OH, Br has been replaced by this. What is replaced by what? Br has been replaced by OH minus. Means it is not an elimination, it is a substitution. But whether it is SN1 or SN2, whether OH minus is attacking in the same side or the opposite side, it is attacking from the back side. Means if it is this is the D isomer, then it is L isomer. It is called inversion. Inversion refers to SN1 or SN2. If it is on both sides attack, it is called as SN1, that is called respoization. But here it is, the product is obtained due to the opposite optical rotation, that is why it is bound to be the SN. Hence, 45 is bound to be the B. 45 in the form of B. Let's have the 46 now. Identify Z in the following reaction series. Identify Z in the following reaction series. What's that? CH3, CH2, CH2Br with aqueous KOH. Aqueous means it is NSR or DHH? NSR. Minus what Br? KBr. That is CH3, CH2, CH2OH. Okay, this is I think X. This on treating with Al2O3. Best example for a dehydrating agent means removal of water. Removal of water means OH has been removed. From the adjacent carbon atom you will have this. CH3, CH2. This is called as Y, I think. Then this on treating with HOCl, hypochlorous acid we are calling. Hypochlorous acid. Here OH minus and then the Cl plus. According to the Markovnikov rule, negative has to be attached to the least. There is a negative here. OH minus. And then the positive is going to be this. Where the product is CH3 CHOH with the CH2Cl, CH3 CHOH with CH2Cl. Therefore, it is going to be the B. 46B. Which of the following do not form the Grignard reagent? As if I already mentioned, RMgX. Here, X cannot be F. All halogens are possible, but not this one. Why? Because they are highly exothermic. And also, as if we know that Grignard reagents are highly unstable when it is exposed to the air, because they readily absorb the moisture to form respective hydrocarbons. That is why they have been kept in only the ethers. Ether acting as a solvent, and also it dissolves the Grignard reagent. But the case is not in case of fluorine, because fluorinated Grignard reagents are highly exothermic. That is why the option is going to be the A. 47 is going to be the what? A. Let's have the 48 here. Molecular formula, which one? Chloropicrin is. Chloropicrin. What is it? Chloropicrin first. I think you have heard about chloroform. When this made to react with concentrated nitric acid. Concentrated what? Nitric acid. It forms CCl3NO2 plus H2O byproduct. This is called trichloro methyl nitrite. Nitromethane. Trichloronitromethane. Trichloromethyl nitrate, which is called as chloropicrin, and it is named as tear gas. An example for a what? Tear gas. Means CCl3, that is 48 in the form of D. Means the nitration of chloroform gives what? Chloropicrin, which is chemically called as trichloronitromethane. 48 in the form of D. Let's have the 49 here. the compound A, what's that A here? In the reaction, first I have to write the reaction for that. A, 49A reaction first. I will write the reaction for that, 49. CCl3 with what? 1 equivalent of bromine in presence of iron. I will write the products here. The product is first CCl3 with Br. Then here B is CCl3 with Br at the ortho position. Then CCl3 with Br and then the Br at this position, and then the D is found to be the CCl3 with what? Br. So here, what is the product that has been formed? It is what's the product here? So if it is if it is ERG, it is forming mixture of ortho and para. If it is EWDG, it forms the metabolite. Here, CCl3 is EWDG. What is that? EWDG. Why? Usually, this is releasing. This is ERG if it is attached to the benzene. But the same thing when it is attached to this benzene. This is withdrawing, this is withdrawing, this is withdrawing. Therefore, this CCl3 becomes what? EWDG. EWDG means it favors only the what position? Meta position. Which is the nucleophile? Sorry, electrophile here, Br. Therefore, it is. Hence, 49 is found to be the A, because CCl3 is an example for a what drawing? Electron withdrawing. It prefers only the meta position. Hence, it is called as meta-bromo trichlorobenzene. Sorry, trichlorotoluene. 49 in the form of A. Next, we will have the 50th here. A small amount of what? A small amount of alcohol is added. A small amount of which one? Alcohol is usually added to the chloroform bottles. Why? Because it retards the anesthetic property of chloroform. It retards the oxidation of chloroform to phosgene. It retards or it converts any phosgene form to harmless ethyl carbonate, and then both of this. We know that when it is exposed to the air or this one, it forms phosgene. What's that? Phosgene. Phosgene is called as carbonyl chloride. Carbonyl chloride. To prevent that, we are adding the what? Small amount of what is added here? Alcohol is added. Means first it retards the oxidation of which one? The process is called as oxidation. Alcohol prevents the oxidation of what? The chloroform to phosgene. In addition to that, it converts any phosgene that has been formed into ethyl carbonate, C2H5 C. That is why, that is both, which and which is the B and C. Okay. So I think this completes the second session of the which one? The MCQs related to the haloalkanes and then haloarenes. Okay. We left with another one. We can solve another 25 to 26 or 28 problem numericals. So totally we can have the 100% completion of the which one? The haloalkanes and then the haloarenes. Okay. So that I will continue in the third session of the haloalkanes and haloarenes concept. Okay. Thank you very much.